everybody. And again, good evening and welcome to our weekly sessions on AI ML. So, as we promised, we'll be bringing you a wide spectrum of topics. So, today we are here with Angulia Yang for learning about computer vision. As we promised, we'll be bringing you. You've been following Angulia. She's a frequent speaker on Women Who Code forums. And we have shared the state somewhere in January where we discussed about debunking AI myths about robots and machine learnings and AI failures and successes. And she has received her education from NUS with a master's in computer science. She has 4 years of experience working with machine learning, computer vision, and she's also developed several vision projects including medical image analysis, video analysis, surveillance, and autonomous driving, so which is like the robotic and self-driving cars, which are of the utmost importance nowadays. And she also is of the opinion that there is no single best AI approach that works for every scene, so she's actively exploring more innovative methods to deploy and to get the AI to work. And with that, we are all set to listen to Angulia's take on computer vision today. So, yeah, it's all yours, Angulia.
Okay, thank you, Priyanka, and thanks to for inviting me. This year's a tough year. Hope everyone is okay and stay safe. Okay, so since my major research topic is highly related to computer vision, and I've been working in industry for years in this area, and beyond that, I'm also part of the researcher and also keep track of all the updates in this faster growing community. So today I'm gonna share you with some my understandings and also sharing with some evolution of these computer vision techniques, and also about the future trends of this computer vision research and also application. Of course, I know every computer vision classic tutorial or talk will begin with MNIST, handwritten digits tutorial or workshop, right? But today I'm not gonna do with that because I knew not everybody maybe have more or less knowledge about like image classification with deep learning, and this is all involved in the computer vision developing history. So I will give everyone an overview of how the current computer vision, the community and their research, their application growth, and how about the progress for now, like 2020, right? And then I will try to go a little bit deep into the specific task, like for the essential task like image classification, object detection, and also image segmentation. These are all the basic but essential tasks in this vision community. With the knowledge, I won't go very deep into the mathematical way or into very detailed, but I will give you a blueprint of how these tasks evolve and how the characteristics was added within this process. Then we're gonna discuss and maybe talk about the potential trends in the future of this computer vision, because like years ago, maybe there's still a question about whether should I join AI or not. Well, now I guess the answer is basically yes. But with this year, we say current 2020, how to choose a specific topic or specific task to dig in to make AI empower your work, your industry, that makes more sense. So that's what I want to bring to all these audience today. Okay, so let's get started. Oh, can you see the screen well? And from my part, okay. Okay, so computer vision is right now currently changing our life. Say computer vision, which is like very initial trace back to 1960s, but then we get all the eyes on till the deep learning burst out since 2012. So current computer vision and also the computer vision mentioned today will be all the deep learning based computer vision. Okay, so today this computer vision is all powered by the deep learning algorithms, and the deep learning algorithms basically is a special kind of neural networks for images. More commonly used is convolutional neural networks. So with such algorithms, we can more effectively make sense of these images, and those networks are trained based on thousands of input data samples, the images so-called, and such images helps the neural networks to be more accurate, to be more specific to your task. And now basically this convolutional neural networks is basically everywhere in most industries. So considering like for the face recognition, say for currently in Singapore, once you enter Shenzong or Fair Price supermarket, there will be a temperature thermometer, right? And that will also involve using the face recognition, and also for fingerprint recognition, it's also use some of your biometrics. And in other industrial, like for the self-driving vehicles and medical diagnosis, like for the eye disease or the biopsy images. Once we simply took the images, we can diagnose the early disease like a junior doctor. And also in manufacturing and surveillance companies can use such computer vision techniques to help tracking people or help to control the people workflow. And till now, this community has been widely applied into the real world life, but beyond, they are still quickly expand in other research areas or other applied domains. So, okay. Okay, so first let's take a look at this top conference of computer vision research. For computer vision research, the top conference will be the CVPR, so-called, so computer vision and pattern recognition. And sorry. Yes.
what are you trying to get done, Angulia?
Yeah, I'm trying to project the presenter mode. Okay, let's continue. Okay, so let's first start with academic world. For academic world, the CVPR is the top conference for this computer vision research. So the state-of-art research and ideas, innovations will be published on this conference proceedings, and we could see since 2012, after the occurrence of our deep learning decades, there will be a directly increase for those paper submission, and we could see that people are very passionate about this area for the computer vision research, and also for the attendance trend, we could also see this directly goes up in the past 10 years. So still there are many people are trying to get involved into this AI world or into this computer vision community to enable their applications or enable their research. And in recent years, we could also, I summarize sort of the topics in the CVPR, and we could see like for now we could see some sort of trends in the current research. For the first, of course, the recognition problem is always the first problem in the computer vision. But in recent years, something interesting trends I'll see and would like to share. One is like the transfer learning, or so-called the semi-supervised and unsupervised learning are getting noticed more and more often. Since like we all know, for the traditional like ImageNet and the Cipher-10, those existed big data sets has been trained well, and now people are wondering like how better we could be like a human learn, say like for our traditional deep learning neural networks, we use thousands of images as input feeding. But for people when learn to recognize an object, we don't need to thousands of samples to recognize, right? So now there's a trend is to get more close to the way of how our human brain works. And this is one very interesting trend in recent years, in recent the current research. And on the another part is 3D data with some sensor equipped and enabled in recent years, and with also some open public data set has been published. Now 3D is also another trend for this year's research. Say like from previous years, we are working on only 2D, the plane, but now we'd like to know the whole view of these objects, which is a higher level understanding. And beyond that, we noticed there's also another very interesting topic arise, which is a fairness and accountability and transparency ethics in the computer vision. Because we see like in medical image analysis and the famous autonomous driving, which all involve some law issues or ethics issues about this technique, and also the laws, the rules. So how do we justify, and how we better utilize this AI to empower our life rather than being abused? So this is also an key issues of this topic. So I'll show this basically transitions from the academic world, and this academic world also gives some indication for those practitioners who are newly joined this community and would like to contribute more and would like to explore more new things. This can be and this can be a very good trend for you to explain and to see how you can use the existing work to expand your own works. And this is basically from the academic research, their current status and or their current focus. And beyond that, we also could see that for their from the business perspective, we could see since last year in North America, the artificial intelligence market has already reached 11 billions. And according to the Fortune forecast, till 2027, there will be 260 billions of market of this computer vision. So we could see there are more potential chances in this community, and also in the business prospect. For now, some essential tasks or basic tasks like image classification and object detection and object segmentation. Later I will cover that, but yeah, this essential task now has been kind of, we say, mature and being successfully deployed into our daily life, like our face recognition, our traffic surveillance analysis software sort of things. But some, like we call those semi-supervised learning, and about the 3D learning, and sort of like adversarial learning about the security of this computer vision, about vision tasks. These are also the faster growing business for those who want to make the computer vision research into a product, or in make use in industry. So here's a trend. So we could see there are a lot of expectations still in this area and in this domain. So further, we take a closer look, like say for the specific computer vision market by region. We could see for North America and Asia Pacific, and also Europe, the three parts takes the dominance of the computer vision market. And in 2018, there will be 11 to 12 billions in the whole world market. And according to these three places sharing almost equal 30s to this whole market. And till 2023, there will be also increasing numbers. And also during during this year for the COVID-19, the computer vision has been also utilized for diagnose the lung MRI and lung CT images to diagnose how the patient goes, how their illness goes, and how to justify whether they get affected. So this domain do have some more potentials to increase. So this is basically an impression for those who are new into this community. For I'm sorry. So this is from both the academic world and from the business perspective of how the current computer vision is going and what's the progress we could see for some now the computer vision in both industry and academia world, we have strong basis, but still there's a lot of space to explore and for us to start our business and or to start our new research topic. And what are the key factors about in driving the deep computer vision going? I'll say there'll be three key factors. One is the deep learning, and the second is the advancements of the hardware, so-called the GPUs. And the third is the growth of the data sets. So we start with the first. Deep learning enables the very first convolution networks into a powerful classifier in 2012 in the large-scale image classification competition. So this one is the multi-layer, I say the multi-layer neural networks, the capability of it creating a non-linear mappings from the input to our target, the mapping, and for the complicated hyperplane it created has enabled the current computer vision progress. And the second is also with the help of the GPU comes out, because we all knew like the initial idea of this convolution networks has been occurred as early as in 1989, but with the new hardware like GPUs and for now even TPUs, right? They are capable of processing gigabytes or petabytes of data algorithms and do more efficient the metric computings. And so we can running our so-called training faster and more efficiently. And also it makes lots of application into reality. So now like for the object detection or classification, we can all realize the real-time processing. And the pioneer hardware manufacturers like NVIDIA and Intel are also in their race to create a more powerful and capable hardware to support the future AI development, and also in computer vision, because computer vision in a way is also requires lots of computing resources, since now we're upgrading from the past images resources to the video resources. So the availability of GPU is also another great backup for the deep computer vision growing. And the third part is about this community, also the growth of the data sets. Because of the public data sets makes like numerous images available. So the algorithms, the deep neural networks, different architectures are generated out of it. And this one is also thanks to many like research institutes and companies. They contribute their times, they labeling the data, and they release the resources to the community. And also in the future, we will need more real world like data sets contributed into the research and into the application as well. So with these three factors accelerated, I think that creates the current deep computer vision, this community and this progress. So this is basically, I think, from the overview part of my understanding on the computer vision and its deep learning. So in the next subsection, I like to discuss some essential tasks, because I know there are a lot of advanced topic like generative adversarial network or 3D detection or the adversarial learning and also autonomous driving. But most of these tasks, according to me, they are based on these essential tasks, and these essential tasks give the milestone of this deep computer vision development. That's why today I'm gonna cover like the object classification and the object detection with some semantic segmentation. I try to cover these three we call very basic task in the computer vision community, and try to cover the involvement of these three tasks to make you better, to make you like better understand how this how these tasks evolves, and how the deep neural networks evolve and become the current stage. And then we can further discuss based on the existing works or based on the existing research and application, what are the potential trends for our future exploration. So start with the very basic one is object classification. Object classification basically is a Bool question. I only need to ask whether my target is in or not in this image classification. So among all these tasks, it will be considered as a relative low-level task. And one step more, I'd like to know, like, beyond whether it exists or not, I want to know where its location of my target, or my target class, or my target instance. So that comes to the definition of generic object detection. And beyond that, I'm not just satisfied with the location and the existence, but I also need you to contour the specific instance or specific class into in these images, in this inputting data. So that's how the semantic segmentation and the instance segmentation comes out. So for semantic segmentation, I only need to control the same category, like all these 5 shapes are all in one color because they are in same shape category. But for instance segmentation, which is a more detailed task and also high level understanding, I need the neural networks or the algorithm deep learning models to help me control each object and their corresponding category. Okay, so this is basically the definition of these essential tasks. Then we will go through one by one from the classification to the object detection and then to the semantic segmentation. See how does this classic computer vision task evolve and what new elements was added in each stage they evolve. So yeah, first thing first, because this is the most basic one, as is the basic one as the classification task. So according to the characteristics, we categorize our deep networks into 7 categories. So one is for their spatial-based CNNs, and this one we could see basically is the very early stage and also classic models, including LeNet, AlexNet, VGG, and GoogleNet, which is also the InceptionNet version 1. And in the rather early stage, depth and breadth makes the CNN more powerful in performance. So then we will have the accordingly Inception V3, V4, and they're basically like the deeper, the better categories. So we have the ResNet and also the combination between these two. Then there's the multi-path based CNNs, and here we have the clever connections between all conv layers. So the ResNet and the DenseNet come out, and which also be another milestone. Then another one is the weights-based multi-connection CNN, which also this one's the pyramid net exception, and the ResNext, which is also the changing format from the previous classical models, and also for the other 3 categories. So these all categories basically based on their characteristics, we can also see from this performance results, which also can explain how the classification model evolve according from the 2011 to 2017. So for 2012, the AlexNet came out, which is firstly used the GPUs and firstly reached the very promising performance to beat all the other handcrafted based models. And then the deeper net, the GoogleNet, ResNet, sort of VGG come out, and then can decrease the top 5 classification error into as low as 2.3%. So we could take a closer look, and we could further take a closer look according to the time. As early as, like I said, to the 90s, we have the LeNet and we have the very initial ConNet in this computer vision community. Then, then 2012, we have AlexNet, and in AlexNet, it could be treated as a groundbreaking model, which firstly utilize the GPU and first utilize the multi-layer networks, and also like the 3 factors. The data was prepared for the large competition, and the GPU was set up that time, and also deep learning was first time show its power in this image competition. And then in 2014, we could see this time the Inception family, so-called the GoogleNet family, comes out and takes the dominance. Then later we have for the better parameter optimization, we have VGG, and we also have the ResNet and DenseNet based on their specific layer connection design, and also with skip connections, we have ResNet. And in the later, during the 2016, we have PyramidNet, which explore the weights in the convolutional networks. And since then, we have one more milestone, SENet, which further explore the feature map. So, and later, the attention mechanism was also involved in this convolutional architecture designing. And till 2018, basically we could see there's almost the end of the architecture innovation exploration, because till now we can have very least effort to train a network to apply our image classification. But in 2012 to 2014, these 2 years, there are many new ideas about the different convolution design or network design comes out. And yeah, so basically now the image classification is also was considered as a very basic and mainstream application in the industry. Okay, so with the basis of the deep learning comes out, and also the deep classification comes out, the traditional object detection task also got evolved quickly in these years. We could see like before 2013, there's no such deep-based detector comes out. And after the AlexNet and DetectorNet, we come out our famous RCNN. The first RCNN comes out to apply for this object detection. Then the SPPNet, which used the spatial features of the pyramid network architecture, also comes out to better understand the different scale of the features. Then was the RCN family takes the dominance. And since the RCN families have a sort of problem in the efficiency, more advanced, or we say one stage detector such as ULO and SSD was also being proposed, and being now, which is also widely used in the industry, these two models. And later there's also mask RCN, which can also can both deal with the image segmentation and also the image detection at the same time. And we could see also like they keep we could basically the same pace with the image classification. So till 2018, they sort of converged to they converge to a very mature state, and basically this is the current object detection environment. But still, yeah, there's multiple new methods coming out, which with more fine tuning and also some advanced technology integration into all these existing works. But we could see like for these works, they become the current mainly use the backbone or mainly use the basis for their modification and updates. So we could simply take a look on the categorization of this detection task. One is we could basically the RNN family, the RCN family, which is a region-based two-stage frameworks. They can process the whole images, and we use like the architectures, borrow the architectures from the image classification task for those layers, and we extract the features. Then for these two-stage frameworks, their feature is there will be a proposal extraction stage for extract multiple the multiple bounding box, and then we regress the final answer, and also do the classification for each region of interest. So this one is also highly increased the performance, but somehow it was time consuming, and we could see the two-stage is not very efficient. So that's why the YOLO and the SSD, those representative of one-stage frameworks comes out. So they do not require generate object proposals. So they consider only a tiny subset of the output space, and they directly go one pass to classify the small set of the bounding box of our potential predictions. Yeah, and they can basically retrieve faster inference, and which is also suitable for the real-time target detection. So this is basically the growing of the detection. We could see basically the detection also keeps the same space with the image classification. with the groundbreaking, the representative models has been proposed, like the RCN series and the YOLO series. Now the modification and also the updates are basically inherited from these established we call traditional models. And the last one I like to briefly mention is for the segmentation for 2D images. Segmentation is also considered a high-level image understanding tasks, which now has been widely used in the autonomous driving and also medical image analysis. So we could see in 2014, so the very first fully connected network, which is also very well known, comes out. Then some of its variation continue, and also the very special UNet and the VNet comes out for basically for the medical images analysis. And during this period, the pyramid, because the pyramid networks also are involved into a better in the performance improving stage. And then mask RCN and the deep lab V3 these were like also well known and now commonly used model are also come out. And then there are some more like path aggregation network and the HRNet, and also later the attention was introduced, and the dual attention network comes out. And for now, like the deep lab is also being widely used for the maybe as the backbone, or maybe as the final model in the real world use, or maybe in the research papers. And you can see there's also a converged process from the very first groundbreaking work from FCN to the current, like the rather mature deep lab V3, and also like attention network or HRNet. So these are the three very essential and very basic tasks of the computer vision. We could see there's expositional increase or very quick changing period, basically focusing on the 2014 till 2018. And during that time period, many classic methods like our currently used ResNet, InceptionNet, and the faster RCN, YOLO, and also here like mask RCN and the deep lab has been widely used. And during this period, they come out during this period. And for now, we'll see for this from scratch, I say like from scratch methods reconstruction for this basic task, which currently is few, because now for all the existing data sets and for these tasks, these these models now can cap like most of the efficiency problem, and also about the performance, about their accuracy. So we could see for those, if you are very interested in how to make your idea combine with deep learning, combine with deep computer vision, and make into product, try to commercialize your business with the help of deep CNN. And I would suggest like for this mature model, and for they might be the best choice for you to give a first try, because these traditional models now, after 2 to 3 years, they raised a very large community to contribute and to deploy in different devices, like in mobile, like in the mobile phone, or in FPGA, or in the web serving. So these tasks and these models are rather mature and ready to industry for this current stage. And but for the like research exploration, and for the further like the architecture exploration, I would say there's maybe relative limited space for this task. Recall like our 3 factors, because the new coming public data sets is also follow a curve, almost like these 3 tasks till 2018 or 2019. Basically, there are no much more public data sets comes out. And for the existing benchmarks, those models can handle very well. So if you are try to start with a business or start with application, I would suggest maybe you can start with those traditional or classic model first, and to give a shot with your first try and application. And for those who are very willing to see what will comes next, this is basically personal, my opinion from my like daily paper reading or daily report reading from this year's AI report, and also the conference proceedings. I'm gonna briefly share with you. So one trend will be the generative models. We also say the GAN and the VAE. Basically, they are 2 different architecture. There are 2 different types of network architecture, but they're doing the same thing. That's generate the very realistic the pictures. So this one currently has been widely applied both in application, but application with say more like it's entertainment. Like recently, you can generate a makeup based on your original input, or maybe you can style transfer other ones, the face, or you can style transfer the Monet or Van Gogh, their paintings, the style, to create some artistic pieces. So this one still currently remain large space in the in the research, because because current the generative model training is very unstable, and which is also resource consuming. So this would be a great direction to explore. And if you want to try how you can generate a different look or even non-exist pictures, maybe you can try with the existing GAN networks. I'd recommended you to check out with some works out from the NVIDIA AI. They've developed sort of a style GAN and some very high resolution generative models to generate the high resolution human face pictures. And this one should be very interesting and also can be applied in sort of entertainment application or networks, like the face swap application sort of things, and also like previously very well known the deepfake. Yeah, and another trend is vision combining language and natural language processing. Because for now, I mean basically basically due on the 2D images, which is the RGB images we are basically focusing on. Their grid-like matrix in the network or in the computer system. So, but for the language, they are not that structured as image can be. So there's still a lot of the difficult dilemmas and problems still exist in natural language processing. So this one would be a very interesting perspective to try to combine the language processing with the image to give a high level understanding. So because for people, we are not just looking, we are also hearing, and maybe we're also writing. So our understanding is multi-dimensional, not just focusing on one thing at the same time. So this one could also be considered as a high-level tasks. And for now, there are continuously some data sets are released for this task, and also the research progress of this visual question answering, which is also like the language and images task combination. This one is not very don't have very mature or classic models like object detection, object segmentation. So this one can also be a very potential way to guide maybe your research or your application. And another thing is also the comes out in recent 2 years, which is the 3D object understanding. Also the understanding maybe including like the pose estimation and the segmentation or tracking or the action recognition sort of things. So also this one should thanks to the availability of the 3D data set comes out, because previously for the 2D images, one difficult part is that we cannot see the overview of our target images, especially in the task of the person domated, like in the person re-identification. We need to access the front view, the side view of the same person, then we can verify his identity. And misidentification also always happen in this hard occasions. So when the 3D data is come out, or the 3D reconstruction is enabled, this problem actually can be solved rather easily, and which is used to be very difficult in the 2D dimension. And that's why I think this is also a good subdirection to explore. And I think it's now 1 hour already. So okay, thank you everyone for joining me today. And later in the question answering session, maybe we can discuss more about my personal sharing. And if you got any questions, or just
we have a couple of questions, Angulia. Okay,
Sure.
So Jason is asking for Q&A. In your opinion, how for enthusiasts, for people who are just starting out, how can they get involved into developing their own code for computer vision applications, or is it just limited to published algorithms?
So due to this visual question answering task, sorry, I maybe missed the question.
No. Jason is asking that, how if someone wants to develop their own CV application, how can they start off? From where can they start?
How can start a CV application, right? Yeah. Okay, so for start, I suggest maybe because for the basic advice, will suggest you to try out MNIST digit recognition tutorials, sort of things. But I say maybe you can pick a specific task you are extremely interested, and then I think GitHub can help you to find a very high star like repository or some example project, and I think you can refer to their implementation, and then try to update on your site, and also like read their code first, and do the modification based on what you would like to change, and see the effects when you change sort of like parameters or layers. And this maybe can help you to fastly understand the specific task you want to dig in. Yeah, this is.
All right. I hope, Jason, that answers your question. And again, another question from Jason is, if you wanted to, build a system which recognizes actions in a sequence, like, some actions in a sequence performed in a sequence, what kind of algorithm would you suggest?
Oh, so for the action recognition, I recommend like there are two models I remember called I3D and C3D. These are the basically also a well-known algorithm developed and the deep learning based. These two models maybe can help you, and this is basically due to the action recognition in the video sequence. Yeah. I think you can refer to these two existing methods and check it out first. Then maybe if you have another idea, you can develop on your own. Yeah.
All right, all right. And another question, a small one, is that, I think in your slide deck, there was something where it could translate a word when you click on that. So people are asking what was that application you are using that can translate a word in an image?
Translate what in the image, the
Word,
app.
yeah.
For that,
I think they saw that in your presentation, in your slide deck.
That was my translating app, which
Okay.
is a wrongly
Okay.
displacement.
Okay. All right. Okay, so that's it. And if I mean, people who have any questions, any further questions, they'll reach out to you on your LinkedIn if they have more questions or more insights to discuss with you. And
Sure.
thank you for the session, Angulia. Thank you for spending time with us. Thank you for this absolutely wonderful deep dive into computer vision. So I kind of like the 3D, action rendering model. It was very interesting. And thank you so much. We look forward to having you again in case, you have more interesting things to share with us.
Sure. Thank you, Priyanka. Thank you for inviting me.
No problem. A pleasure to host you. Have a good day and stay safe.
Okay. Thank you. Thank you all
You.
to join this. Thank you.
Bye-bye.
Bye-bye.
Hi, Setu. Okay, I think Setu is away, Angulia. So, yeah, so I'll be dropping off. Hello?
Hello?
Yeah, I said I think Setu is away. So, I think I'll end the meeting. Okay? Okay.
Thank you.
Thank you so much.
Thank you.
Bye-bye.
Bye-bye.
Good night.
Good night.